Humidity is the amount of water vapor in the air. Relative humidity is defined as the ratio of pressure of water vapor in a parcel of air to the saturated vapor pressure of water vapor at prescribed temperature. Humidity may also be expressed as specific humidity. Relative humidity is an important metric used in forecasting weather. Humidity indicates the likelihood of precipitation, dew or fog of the various components of atmosphere. Water vapor constitutes a small fraction varying nearly 0% to about 4% volume. Three states of water. Water occupies all the three states of matter: liquid, solid and gas. In the frozen or solid state, it is ice. In the liquid state, it is water, and in the gaseous state, it is water vapor. By the process of evaporation, water in its liquid form is converted into gaseous form or water vapor. Since the similar change of state from ice directly to the water vapor is termed as sublimation. By condensation, water vapor passes into liquid state or water. However, if the temperature of water vapor is below the freezing point, it may pass directly into solid form or ice. The process is called sublimation. Freezing water may pass from liquid to solid state, and by melting, it may pass from solid to liquid state. The change of state from liquid to solid is called as freezing, and from solid to liquid is called as melting. In the figure, the three corners of the triangle depicting the change of state of water presents its solid, liquid and gaseous forms, while 6 possible changes of state by different processes. The circulation of water from one part of general earth system to another is known as the hydraulic cycle. Water is cycled endlessly between atmosphere, the soil, surface storage, lakes, streams, plants, animals, reservoirs and the oceans. Even though the water vapor content is almost constant, there are local changes because of seasonal and weather variations. The entire process of maintaining constant water vapor content of atmosphere is known as hydraulic cycle. Moisture loss from vegetation is known as transpiration. The combined effect of evaporation and transpiration from vegetation covered land areas are called evapotranspiration. Thus, the hydraulic cycle involves evaporation, condensation and precipitation. Hydraulic cycle denotes unending movement of water from oceans to the atmosphere, from the atmosphere to land and from land back to the oceans. This cycle of movement of water is mainly responsible for distribution of moisture over the earth's surface. Transfer of humidity. There are two main aspects of transfer of humidity: land-sea moisture exchange, meditorial moisture exchange. Land-sea moisture exchange. There is a continuous exchange of moisture taking place between the continents and the oceans. The amount of moisture gained through precipitation on the continents is more than that lost through evaporation than whatever they receive through precipitation. Wind carries a part of atmospheric moisture from over the oceans to continents where water vapor condenses and falls as rain. However, part of this precipitation returns to the oceans through surface runoff or groundwater seepage. Meditorial moisture exchange. Meditorial moisture exchange involves the transfer of moisture between latitude belts on the earth. This also involves a transfer of energy. In certain latitude zones, there is a marked excess of precipitation over evaporation. On the contrary, there are certain zones where evaporation exceeds precipitation. In each hemisphere, the surplus of precipitation is found in equatorial as well as middle latitude zones extending from 40 to 70 degree north and south latitudes. Evaporation exceeds precipitation in latitude zone of 10 to 40 degrees latitudes. Humidity and temperature. There exists a close balance between atmospheric humidity and air temperature. The moisture holding capacity of air increases with increasing temperature. The moisture holding capacity increases slowly at low temperature and more rapidly at higher temperatures. The amount of water vapor that a given parcel of air can hold at a given temperature is referred as its capacity. Vapor pressure. Vapor pressure is the part of total atmospheric pressure, which is attributable to water vapor content. As water molecules evaporate from water surface, there is small increase in pressure in the air above. This increase is the result of motion of water vapor in the air tend to return to the liquid state. Humidity measurements. The moisture content of atmosphere in any place can be measured in a number of ways. The following expressions are used to denote the actual moisture content of the atmosphere: the absolute humidity, specific humidity, and relative humidity. The absolute humidity. The weight of water vapor per volume of air is referred to as the absolute humidity, usually expressed as grams of water vapor per cubic meter of air. Specific humidity. It is the weight of water vapor per weight of a given mass of air including the water vapor. The specific humidity of air changes only as the quantity of water vapor undergoes a change. Specific humidity is not affected by changes in pressure or temperature of the air. Specific humidity is directly proportional to the vapor pressure of air and inversely proportional to the air pressure. Maximum amount of specific humidity is found in equatorial zone and maximum at the poles. The amount of water vapor present in the air near equator is much more than what it is in the polar regions. Specific humidity in a particular region is much higher in summer than in winter. Relative humidity. Relative humidity is defined as the ratio of the amount of water vapor in the air to the amount of air can hold at that temperature. In other words, the relative humidity is the ratio of the air's water vapor content to the water vapor capacity. This ratio is always expressed in percentages. Any decrease in air temperature will result in an increase in relative humidity. On the contrary, any increase in air temperature will cause corresponding decrease in relative humidity. Evaporation is a process by which a liquid is transformed into gas or vapor. The atmosphere receives the moisture through evaporation from the oceans, lakes, rivers, etc., and through transpiration from plants. It takes about 600 calories of energy to convert 1 gram of water to water vapor. This energy is released as heat where condensation takes place and water vapor changes back to the liquid state. The heat absorbed in the process of evaporation is referred to as the latent heat of vaporization. When the raindrops fall through the dry layers of atmosphere, the process of evaporation chills the air itself. Factors affecting rate of evaporation. Rate of evaporation is greatest over oceans than over continents. Evaporation is also affected by temperature. As the temperature of the air increased, their capacity to hold moisture also increases. Evaporation is directly proportional to the temperature. Warmer the evaporating surface, higher the rate of evaporation. The rate of evaporation is closely related with the relative humidity of the air. Since the moisture holding capacity of air at a given temperature is limited, drier air evaporates more than water than moist. In other words, higher the vapor pressure, lower the rate of evaporation. Evaporation depends on the wind speed as well. When the wind are light, a thin layer of air just above the surface gets nearly saturated. On the other hand, when wind's velocity is high, turbulence is set up in air. Whenever there is a combination of high temperature, very low relative humidity and strong wind, the rate of evaporation is exceptionally high. The rate of evaporation is also determined by the area of exposed surface to water. Evaporation is also affected by the atmospheric pressure. Lower pressure in open surface of the liquid results in higher rate of evaporation. Evaporation is inversely proportional to the salinity of water. The rate of evaporation is almost greater over fresh water than over salt water. Ocean water vapors 5% more slowly than the fresh water. Potential evapotranspiration. The term potential evapotranspiration refers to the idealized condition in which there would be enough rainfall to provide sufficient moisture for all possible evapotranspiration in an area. Several factors like temperature, latitude, vegetation and water retaining capacity of the soil are responsible for evapotranspiration. Distribution of evaporation. Generally, actual evaporation is greater over ocean than over continents. Land area in low latitude between 10 degrees north and south of equator lose more moisture through evapotranspiration than on the oceans. North-south distribution of actual evaporation is largely controlled by air temperature, since temperature decreases from the equator towards the poles. About 60% of Earth's evaporation occurs in latitudinal belt extending from 20 degrees north to 20 degrees south, and 80% occurs in the zones extending from 35 degrees north through 35 degrees south latitude. Condensation is the process whereby water vapor in the atmosphere is returned to its original liquid state. In the atmosphere, condensation may appear as clouds, fog, mist, dew or frost, depending upon the physical condition of the atmosphere. Condensation is not a matter of one particular temperature, but of a difference between two. Condensation of water vapor occurs when the temperature of air is lowered to its dew point. All air contains water vapor of varying quantities. When air is cooled, relative humidity increases until a particular temperature called the dew point. The air becomes saturated. Further cooling below the dew point will induce condensation of the excess water vapor. The temperature of the dew point will depend upon the absolute content of water vapor, that is absolute humidity, measured in grams per meter cube. The dew point of humid air will be higher than the dew point of dry air. Both air temperature and absolute humidity will determine what type of condensation will occur when the air is cooled. If air in contact with the ground is cooled to its dew point, dew or frost will form. Dew if the point is above 0 degrees centigrade or frost if the point is below 0 degrees centigrade. Cooling of a larger layer of air near the ground may produce mist or fog which freezes if the dew point is below 0 degrees centigrade. Air that is cooled to its dew point by raising and expansion will condense to form clouds. Above 0 degrees centigrade, small droplets of water are formed. Condensation may also result in ice crystals at temperature well below 0 degrees when temperatures are near or a little above 0 degrees centigrade. Supercooled water droplets can form. Condensation is a process of water vapor to the liquid state when air becomes cool below its dew point. Water vapor becomes liquid. Further cooling of saturated air starts the process of condensation. Whenever the temperature of dew point falls below freezing points, that is 0 degrees centigrade, it converts into ice by the process of sublimation. Necessary conditions for condensation. As noted earlier, condensation takes place when water vapor is converted into liquid form. This process may produce fog or clouds. First condensation to occur, saturation of air is an essential peer required. Secondly, water vapor needs some kind of a surface on which it may condense. Dust particles or aerosols may help in the condensation process. Besides, the relative humidity should reach above 400%. As the relative humidity reaches 100% mark, condensed water particles grow larger in size very quickly, thus cloud starts appearing in the sky. It is important to note that there should be an abundant supply of microscopic dust particles to get the process of condensation to start. Condensation does not occur on ordinary dust particles. Thus, dust particles should be capable of attracting or absorbing water. These condensation nuclei are called hygroscopic nuclei. They are of the following, which include sodium chloride and magnesium chloride. Sulfur dioxide, which oxides to sulfur trioxide, which evenly becomes sulfuric acid when mixed with water. Oxides of nitrogen, specifically nitric acids. Active volcanoes, forest fires are the sources of large number of such hygroscopic nuclei. Salt particles from the oceans by winds are supposed to be the most powerful condensation nuclei. Condensation occurs in various forms depending on the amount of humidity in the air, temperature and rate of cooling. The common forms of condensed moisture include dew, frost, fog and clouds. Dew. Dew consists of tiny droplets of water produced by condensation. In fact, dew refers to water drops deposited by direct condensation of water vapor cooled by radiation. Clear skies and calm air are necessary conditions for formation of dew. Cloudless skies, calm weather, sufficient quantity of moisture are the prerequisite conditions for the formation of dew. Frost. Frost occurs when the dew point of air falls below freezing point, that is 0 degrees centigrade. When condensation starts with temperature below 0 degrees centigrade, water vapor converts directly from gaseous to solid state. Low places such as valleys are the ideal conditions for the occurrence of frost. In such locations, cold and heavy air accumulates where temperature inversions takes place. Protection against frost is a great challenge to the fruit growers in some cold countries. This includes covering plants with materials having low thermal conductivity such as paper or cloth. Giant sized fans are frequently used for warming the air. Condensation is the formation of liquid drops from water vapor. It is the process which creates clouds and so is necessary for rain and snow formation as well. Condensation usually occurs when a parcel of rising air expands and cools. A very important part of this process is the release of latent heat of condensation. This is the heat that was absorbed when the water was originally evaporated from the surface of the earth. The only thing that keeps all of this evaporation from filling up the atmosphere with water vapor is precipitation. Rain and snow are continuously forming within clouds and falling back to the surface, completing one element of the earth's hydraulic cycle.